I think this video is going to be an epic one because it covers a very useful trick, a topic that comes up a lot in the GRE and GMAT and in real life, and I've never covered it before on my channel. So, what am I talking about? I'm talking about those kind of questions where you have two objects or people heading towards each other and you have to use some sort of fancy trick to work out either when they cross over or how far apart they are. Those kind of harder speed, distance, time questions. I call them relative speed questions for a reason you'll see later on in the video. Either way, I've got 3 questions in roughly ascending order of difficulty. You might disagree, but all of them are relatively hard. I would say either upper, medium, or all at the hard level. So feel free to pause the video, attempt every single one. It'll actually be a minority of students who can do all the questions without any help at all. So get ready to learn something. What question are we talking about? Let's do this question 1. Train A leaves station P at 12 noon, heading for station Q at 60 miles an hour. Train B leaves station Q at 12 noon, heading for station P at 40 miles an hour. So you can draw a diagram if you want, but they're heading towards each other. One going at 60, one going at 40, both leaving at noon. If the distance between the two stations is 200 miles, how far from station P is the point at which the two trains cross each other? Now, without a good method here, this question gets really hard. But I've got some good news for you guys. I've got a good method. So, what is my method? Well, step 1 is we add the speeds. Why do we do this and when do we do this? When we do it is when two things are heading towards each other. And that's why I've given the title to this video, Relative Speed Towards Each Other. When two things are heading towards each other, you can, if you want, add the two speeds together. That's, I think, the best way of solving it. As for why this works, well, have you ever had that feeling where you're on a train and then another train is coming from the opposite direction, and when the trains cross, it seems like they're going really, really fast? That's relative speed because the two speeds are being added up. So if one train's going 100 miles an hour, your train, and the opposite train is coming towards you at 100 miles an hour, they're crossing each other at a rate of 200 miles an hour, which is why it seems to go so fast. Now, another video for another day, hopefully fairly soon, will be a relative speed question where we are catching up, but that's a different category. This video is for heading towards each other. So that's a little bit about why we add the speeds, but either way, let's add the speeds. We've got one train going at 60 and the other train going at 40 for a combined speed of 100 miles an hour. I know neither of the trains are going at that speed, but that's the relative speed. That's the speed at which they're crossing that distance between them. 100 miles an hour. What's step 2? Step 2 is always to apply the triangle using our relative speed. So they're covering the distance at a combined rate of 100 miles an hour, and the distance between them is 200 miles. What triangle am I talking about? This is how I answer all distance, time, speed questions with the triangle, because it's a great way to easily see what you need to do. We have a relative speed of 100 miles an hour, and we have a relative distance of 200 miles because they're 200 miles apart, and the triangle tells us to do distance divided by speed. 200 divided by 100 will give us 2. And using the triangle, we can see that gives us a time. So it takes 2 hours for the two trains to cross each other. Notice we didn't focus on one of the trains or the other train. We used a combined measurement. Combined, they're going at 100 miles an hour. The distance is 200. Distance divided by speed equals 2 hours. But that wasn't the question. The question wasn't how long will it take for them to cross each other. The question was how far from station P is the point at which the two trains cross each other. Well, we know it takes them 2 hours for them to overlap or cross over. So all we have to do is pick one of the trains, say let's do the easier one, train A, and he's going at, or the train is going at 60 miles an hour. 60 miles an hour for 2 hours will be 120 miles. So that's why I've said step 3, if needed, it's not always needed, step 3, is applying the triangle again. We know train A was going for 2 hours, because that's what we worked out in step 2, and we know it was going at 60 miles an hour. 2 times 60 is 120. By the way, the triangle, if you didn't know already, told us what to do. Time times speed. 2 hours times 60 miles an hour equals 120 miles from station P. Some of you are thinking, couldn't we have used the other train? Yes, we could. It would have been 40 miles an hour times 2, giving us 80 miles, but that would have been 80 miles from station Q, so 120 miles from station P. So the answer is 120 miles from station P. Notice the 3 steps because we're going to be using them again. I've called them the 3 steps of glory at the bottom. Step 1, adding the speeds. Step 2, applying the triangle. And usually there's a step 3 where you have to apply the triangle again. Remember, all of this is exclusively for when 2 objects are moving towards each other. Okay, next question I made up. Harder, I would say, significantly harder. And then we've got a third question as well. If you want, you can pause the video, try this one yourself. And if not, I will explain it right now. Okay, so we've got train X leaves station 1, heading for station 2 at 140 miles an hour. It's a bit more realistic speed, I think. Train Y leaves station 2, heading for station 1 at 100 miles an hour. If the distance between the 2 stations is 150 miles, after what 2 times are the trains 30 miles apart? It's that last bit that will confuse a lot of people, but we're going to follow the same 3 steps. Step 1 is adding the speeds. They're heading towards each other, so we add the 100 miles an hour and the 140 miles an hour for a combined speed of 240 miles an hour. Now step 2 is going to be to apply the triangle, obviously using this 240 combined speed. But what distance do we use? It said that the distance between the stations is 150. The question wasn't when do they cross over, because then we just used 150. The question was, after what 2 times are the trains 30 miles apart? Meaning the first time, they haven't quite yet caught up that 150 miles. They haven't crossed over. They're still 30 miles apart. So the first time that they're 30 miles apart is the time where they haven't quite covered that 150 mile distance between them. So how much distance have they covered? If the total is 150 and they still have got 30 miles left to cover, 120. So they will have combined covered 120 miles. Obviously step 2 always requires a second ingredient, and we know the combined speed is 240, and that missing second ingredient was the relative distance, which would normally be the 150, but it says they're 30 miles apart, so they haven't covered the full 150. It's 120, which is the relative distance for the first calculation. Obviously, again, we use a triangle. 120 is a distance, 240 is the speed. Distance divided by speed gives us 0.5, and that would be hours according to the triangle. 0.5 hours is, of course, 30 minutes, meaning after 30 minutes, they're still 30 miles apart. So we know it's going to be C or D. But what does it mean after what 2 times are the trains 30 miles apart? Well, using common sense, if they keep traveling towards each other, they're going to cross over, and then again, after a few minutes, they're going to be 30 miles apart, but this time heading in opposite directions. So here's my question to you. If the second time that they're 30 miles apart, they've crossed each other and then become 30 miles apart again, what's the total relative distance that the 2 trains will have gone? Well, they've crossed each other, so we know they've already gone 150, but they've also gone an additional 30. I'm not saying each of them's done 30, I'm saying combined they've gone an extra 30, so that now they're 30 miles apart again. So they've covered the 150 to cross over, and they've covered an extra 30. So relatively speaking, or combined you could say, they've gone 180 miles. Again, applying the triangle, distance divided by speed, because they're still going 240 combined, 180 divided by 240 gives you, I think, 0.75. And 0.75 or 3/4 of an hour is 45 minutes, giving us answer C. So you can see these questions aren't super easy. Obviously they could come up, especially in the GRE, with a slightly easier version of this question where there's just step 1 and step 2 in a very basic kind of question. But I want to push you guys to the limit, just so that no matter what they ask on this topic, you're happy with it. But you get one last shot at glory because we're going to do one final question. This comes from my guide. Ryan and Brianna are walking towards each other from opposite ends of a 3-mile beach. If Ryan is walking at 2.5 miles per hour, at what speed in miles per hour must Brianna be walking so that they will meet each other after exactly 45 minutes? Now I know some of you are putting your hands up and saying, oh, but Philip, this is different. Like, we don't know one of the speeds. Oh, what do we do? This is impossible. Don't be intimidated. As I've written at the bottom, don't be intimidated from creating a letter. Yes, I agree with you. One of the speeds we don't know, but that's not going to scare us, is it? We just create a letter. Let me show you how we're going to use the same 2 or 3 steps, just like before. Nothing's different really. Just a letter instead of a number. Okay, what was step 1? Remind me? Adding the speeds. So we know Ryan's going at 2.5 and Brianna we don't know. So let's call her B. By the way, some people in the comments will say there's another way of answering this, and I agree, but I want to show you my approach. It's the same as the other 2 questions. Adding the speeds. That will be 2.5 plus B. Yes, I agree, we don't know what Brianna's speed is, but let's just call her B. So it's the same step as all the other questions. By the way, why do we add the speeds? Because of course they are heading towards each other. What would step 2 be again? Remind me? It's applying the triangle. But for the triangle, we need to have another measurement or number. And here we have 2 other numbers. We've got the fact that it's a 3-mile beach and they need to meet after 45 minutes. That's fine. We just apply the triangle in its entirety. What does the triangle tell us? Distance is at the top, so that would be 3 miles, divided by speed, which is 2.5 plus b, equals the time, which I've put as 0.75 hours rather than 45 minutes, because let's keep it in hours. Writing 45 minutes will just confuse us because the question's in miles per hour, so keep it in hours. 45 minutes, you should know off by heart, is 0.75 hours, 3/4 of an hour. I'm going to say this step again because it's really important and some of you would have not got it. Remember, step 2 is to apply the triangle. Sometimes that means you have 2 ingredients and you're finding the third. Other times you have all 3 ingredients, like here. We have the distance they've got to cover, 3 miles. We have the combined speed, 2.5 plus b. And we have the resultant time that it takes, because we need to take 45 minutes or 0.75 hours. So what's the mystery? Well, the only mystery is b. But now we can just use basic algebra to find b. But I hope you notice it's always the same steps. Adding the speeds, applying the triangle, and I think in this question we won't even need a step 3 because we're just going to solve it now. How would we solve that? Well, first thing is we don't like decimals. I don't like decimals. 0.75 is not very nice, and 45 minutes would be even worse because that's minutes. So instead, let's change it to a fraction. Or we could have multiplied both sides by 100, but I prefer fractions. So just get rid of decimals. They really cause a lot of unnecessary mistakes for people. And what I've done in that step, as well as changing the 0.75 to 3/4, is I've multiplied both sides by the denominator, 2.5 plus b. This is called cross-multiplying. Essentially, I've picked up the denominator on the bottom left and brought it up inside some brackets and put it on the right. So it's now 3, the 3 miles, equals 3/4, that's the 0.75, times 2.5 plus b. And that looks easier to me because there are fewer decimals. Second thing though that I don't like decimals, and I also don't like fractions. So you saw how I got rid of the first fraction by multiplying both sides by the denominator. I'm going to get rid of the second fraction now, that 4 on the right, by multiplying both sides by 4. I'd rather do that than multiply 3/4 by 2.5. I mean, you can do that. Obviously in the GRE you've got a calculator, or in the GMAT you could change the 2.5 to 5/2, but I'm just saying this is how I would do it. Multiplying both sides by 4 gives us 12 equals 3 times that bracket. Multiplying the bracket gives us this, Taking away 7.5 from both sides gives us 4.5 equals 3b, so b equals 1.5. Her mystery speed would have to be 1.5. 3 hard questions there, but they all had in common the same 3 steps, or sometimes just 2 steps for slightly easier questions. And this is how to do relative speed when we are heading towards each other.